Welcome back, ladies and gentlemen. This is video 2 of 2 for section 4-6 in your textbook entitled Isosceles and Equilateral Triangles. Here we are going to see the examples for the problem types that will be on your homework assignment. So we'll start off here with a vocabulary-based problem. Here we see a quadrilateral. In fact, this is a kite, which we will discuss later in the course. And that diagram consists of a whole bunch of triangles. There's a total of 8 triangles in this diagram, but we only care about 2 of them. See, we've got 4 right triangles, 1, 2, 3, 4, but we're not talking about right triangles in this section, so we're going to ignore those triangles. And we have 2 scalene triangles here. We're going to ignore those as well, because this section doesn't deal with scalene or right triangles. It deals with isosceles triangles. So what we're asked to do is we're asked to name a pair of unmarked congruent angles in this picture, and we're asked to name a pair of congruent unmarked sides. Now to do that, we have to recognize that within this diagram are a couple of triangles that are not identified. So for the first part, where we're naming 2 unmarked congruent angles, we need to be looking at this triangle right here. That is, we are going to use triangle GJF to answer the first part of this question. Triangle GJF is marked as being an isosceles triangle. We have 2 congruent sides. That means that's the only place in this diagram where we can be 100% sure that the angles opposite those sides must be congruent. Now, a major mistake we've been making in this course is thinking that we can call those 2 angles angle G and angle J. We can't do that. Yes, the vertex is G. Yes, the vertex is J. But there's more than one angle in this picture with a vertex at G. There are actually 3 of them. 1, 2, and then the overall big obtuse angle 3. So we must use the 3-letter approach to naming these angles. Okay? So for the unmarked congruent sides, since FG is congruent to FJ, that means the angles opposite those side lengths must be congruent as well, which means angle FJG, that is this angle right here, must be congruent to angle FGJ, which is this angle over here, because their opposite are 2 marked congruent sides. That is a set of previously unmarked congruent angles. Now, when we turn our attention to the other question here, and we're asked about the unmarked congruent sides, we also need to turn our attention to a different triangle. That would be this triangle, which is also isosceles. Okay, so we're going to use that triangle, which is triangle GHJ, to answer that question. Now, in that triangle, angle HGJ, that's this angle, is marked as being congruent to angle HJG. That's this angle over here. That means that by the converse of the Isosceles Triangle Theorem, the sides opposite those angles must be congruent, which means we can state that HJ, which you could also call JH, is congruent to HG. One of the key skills of geometry that you're supposed to develop during this course is being able to look at a complicated diagram and pull out shapes that you are aware of properties for. So in this picture, even though there are 8 triangles, we're only going to focus on the ones dealing with this section, which are the isosceles triangles within that picture. Now, the other problem type that you're going to see on your homework is problems where I give you an isosceles triangle and I ask you to find various measures. Now, these vary in level of difficulty, and they vary between isosceles and equilateral triangles. So here we see an isosceles triangle ABC. We know it's isosceles because, one, the directions say if triangle ABC is isosceles. And 2, the markings on the triangle itself indicate that AB is congruent to BC. Now that's the exact fact we need to answer number 1. Because AB is congruent to BC, that means they are the same length. So if AB is 11 centimeters, BC is also 11 centimeters. That one should be that easy, that quick to do. Now as for the other two, angle A and angle C, they require a little bit more thought, and they require us to pull out a theorem from a previous lesson which says that the sum of the 3 angles in any triangle, in this case the measure of angle A plus the measure of angle B plus the measure of angle C, must equal 180 degrees. Now I know what you're thinking, but Mr. Wills, we only know angle B. True, but because this is an isosceles triangle, the 2 angles we don't know are the base angles, which means they must be the same measurement. Now we don't know what that measurement is, but by inserting an x for the measure of angle A and the measure of angle C, we can set up the equation x plus 120 plus x equals 180. This equation is relatively easy to solve. It is not even an algebra 2 equation. 2x plus 120 equals 180. We subtract 120 from each side, which gives us 2x equals 60. And then we divide by 2, which gives us the value of x as being 30. Now keep in mind that x is a variable. The measure of angle A, therefore, is 30 degrees, and the measure of angle C is 30 degrees. So we simply have to go over here and type in or write in our answers. Notice that x does not have units, but the measure of angle A and the measure of angle C both have to have a degree symbol because you're giving me a measurement. Okay, that brings us to our last example for this video and for these notes. Here we have a triangle. Now at first glance, this triangle appears to be isosceles because there are in fact side markings on 2 of the 3 sides. However, if you look closely, you'll notice that the angles opposite those sides are not the 2 that are both marked 2x degrees. What this tells us is that the measure of angle C is also 2x degrees. And if all 3 of our angles are 2x degrees, all 3 of our sides must be congruent. So in fact, this triangle is both equilateral and, because it's equilateral, also equiangular. So to solve for x, we are going to use the angle sum theorem again. Measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. To set up the equation, 2x plus 2x plus 2x equals 180. If each angle is 2x, we can add those together. 2x plus 2x plus 2x is 6x. So we're just combining these like terms, and then we're dividing by 6 to give us x equals 30. We do not need to plug that number back in because the directions do not require us to do so. Now for y, it's a little bit trickier, I think. Maybe you disagree. In that picture, we have now managed to mark that AB is congruent to BC, which means that the length of AB is equal to the length of BC because that is the definition of congruence. In the picture, AB is 3 inches long and BC is 4y minus 5 inches, which means that 3 has to equal 4y minus 5. To solve that, that's a 2-step equation. We're going to add 5 to each side, which will give us 8 equals 4y. Then we will divide by 4, which will give us y equals 2. That is it for this set of notes. Good luck on your homework.